Hello. Welcome to the Understanding Reality channel. I'm very happy to see you here. In this video, I will explain our universe to you, my valued viewers, in a simple and calm way. You will learn many things about the universe that you didn't know. Let's begin. The universe is slowly letting go of us. Stop for a moment and imagine this. You look up at the sky. The stars are there. The galaxies are there. But no, not all of them are. Some galaxies did not disappear. They didn't explode or fade away. They didn't vanish. Their light simply can no longer reach us. The universe is expanding. Yes, you heard that right. The universe is expanding. And this expansion is causing some things to slowly drift away from us. So when we look, they become invisible. We can't notice this right now. But as billions of years pass, the universe we could once see much more of is slowly shrinking from our perspective. The universe isn't just growing. At the same time, it is quietly leaving some things behind, without us even noticing. Now think about black holes. We are usually told that black holes form when massive stars die. But what if some of them formed even before stars existed? In the early moments of the universe, everything was so dense that some regions may have collapsed into themselves, before stars, before galaxies. If black holes form this way, we call them primordial black holes. Some may have started very small, some may have grown over time, yet we've never directly observed even one of them, but if they are out there, they could tell us a lot. What is dark matter? How did galaxies form like this? What was the universe like in its earliest moments? Perhaps black holes are the oldest witnesses to how time itself works. They are silent, invisible, but still there. Now, let's understand something even more striking. Can two particles located at opposite ends of the universe be connected to each other? This is exactly what we call quantum entanglement. Once two particles become entangled, the distance between them becomes irrelevant. If you change one of them, the other reacts instantly. This is not sending messages faster than light, but it may be telling us something important. Reality may not be as separate as we think. According to some physicists, these connections might be part of the fabric of space-time itself. They might be one of the things holding the universe together. Perhaps some particles formed at the birth of the universe are still connected to each other, like invisible bonds between galaxies. Now focus on this emptiness space. Is it really empty? No. Quantum physics tells us that even a completely empty region of space is full of activity. Particles appear, then disappear. Fields are constantly vibrating. All of this motion creates energy. We call this vacuum energy. And here's the strange part. This vacuum energy may be causing the universe to expand faster and faster. So what do we learn from this? The more empty space there is, the stronger this pushing effect becomes, as if nothingness itself has turned into an invisible force that pulls the universe apart. Let's return to black holes one more time. We often say nothing can escape a black hole, but that's not entirely true. Black holes lose energy very, very slowly. This is called Hawking radiation. This energy loss is so weak that it is almost impossible to detect. But over time, over unimaginably long times, a black hole shrinks and shrinks and eventually disappears. This disappearance doesn't happen with an explosion or a collapse. It happens with a very long silence. Now, let's look at matter in the universe. We are taught solid, liquid, and gas, right? But these are not the most common states of matter in the universe. Plasma is. Stars are plasma. The space between stars is filled with plasma. Even the space between galaxies contains plasma. It is electrically charged, shaped by magnetic fields, fluid and dynamic. On Earth we rarely encounter it, but in the universe, it is everywhere. What happens when two black holes collide? Can you imagine it? Space itself begins to ripple, incredible. The fabric of space-time vibrates. These vibrations spread across the universe at the speed of light. We can now detect these waves, and every single one of them tells us this. Something enormous happened, very far away. If we look at the distribution of galaxies, from a distance we see strange patterns, but they are not random. They form a network, like threads, knots, and vast empty regions. We call this the cosmic web. Galaxies appear as if they are placed along the skeleton of this invisible structure. The universe looks as if it grew naturally, not as if it was built piece by piece. Now, let's look at the James Webb Telescope. This telescope looks very far away, but what it actually does is look into the past. Some of the galaxies James Webb observes may no longer exist in the same form today. They may have merged or broken apart. But their light is still on its way. Telescopes do not show us now. They show us many different moments in time. And perhaps the most fascinating part, most of the universe is invisible. The stars, galaxies, and nebulae that feel so vast to us are only a small fraction of what exists. The rest is dark matter. It does not emit light, but it holds everything together, like an invisible skeleton. Finally, I want you to focus on this. The carbon in your body was formed in stars. The calcium in your bones came from supernovae. The iron in your blood is the legacy of dead stars. You are not separate from the universe. You are a tiny moment in which the universe became aware of itself. And yes, the universe is watching itself through you. Perhaps that is why the most amazing thing about the universe is this. There is a part of it that can understand it, and that part is you.